any particular gases. Suppose in this time we working with NO2. Suppose how you can easily calculate this total emission of the this NO2 gases in your particular area and particular number of gas emission. Okay, so here you see, suppose this is our study area is Dhaka, only Dhaka district. Okay, only Dhaka district as our study area. So now we first of all we check how many area available in our Dhaka city or Dhaka district. Okay, so we take a variable. Suppose variable name is emission area. Sorry, emission area. Emission area underscore emission area. If you want, you can use any variable name, no problem. Emission area. Okay, already we see that our this data CSV data export. So now we check. Okay, for your better understanding, now we check this data in our CSV file or Excel sheet. Okay, wait a minute. So now we download it. Download it. Wait a minute. Okay, Dhaka NO2 year 2020 CSV. Already we see this name, and now open it. Open in our Excel application. Okay, so now is how you can easily calculate. First of all, calculate your study area. Okay, calculate our study area. Okay, so that's why we use here this function ee dot. Sorry. Okay, ee dot image dot pixel area. All pixel of our study area we calculate pixel area. Use this function. So what is the problem here? Pixel area, or maybe p is capital small. Okay, pixel area our function is working. Okay, so this is our pixel area function. We use the ee dot image dot pixel area, and then we use here the reduce region function. Okay, and call our all of the argument value. Okay, so now we make a dictionaries again, call bracket start and also call bracket int for calculating our study area. So then we reducer, we use the reducer dot sum. Now we use the e dot reducer dot sum. That means sum function we use here because all of the all of the pixel of our study area show as a sum. Okay, sum value as our total area. That's why we use the reducer dot sum value. Okay, and then our geometry. What is our geometry? Geometry is our study area AOI. Wait a minute. Okay, and scale value already we know for this uh, satellite images. Easily copy and paste here. CRS not needed, transform not needed, max pixel is needed. We access max pixel. Suppose same value we want 10 to the power 13. Okay, it's not a big issue. Then we okay now we print this study area. Okay, that means our total emission area of Dhaka district. So we copy and paste here. Okay, now click to the run. So after some time you see here the dictionary is computing. So dictionary is computing object. One object is ready to open. Object is area. Area is, you see here this area. Okay, for your better understanding, I copy this function and first doc sum. This function, okay, this function automatically calculated in square meter. Okay, square meter. So okay, open it. Generate an image in which the value of each pixel is the area of that pixel is square meters. Okay, the return image has a single band called area, not no argument written as an image. That means this image dot pixel area automatically calculate this area as a square meter. So now if you want to exchange it square meter to hectare area or square meter to square kilometer, just you put here this function. Okay, so after some time we will learn all of the things, so don't worry about this. Okay, wait a minute. Okay, first of all we put here the square meter. Okay, we learn square meter. Wait a minute. Okay, so now already we make this type of equation. Okay, so now we suppose we take a variable Dhaka area, another we share the object value. Okay, object value, and another way we learn object will not show object directly, we show this value. Okay, that's why this is the one, this is another way. Okay, so suppose we use the Dhaka area. For your better knowledge skill, I supply this another way. Okay, so suppose we call this emission area, simply copy this emission area. Already we put here the emission area and put it. Okay, so simply copy and paste here. Okay, so now wait a minute. So now we use here emission area, which is the values function. Values function is directly show as our value. Okay, values function, and we set here the get info. That means get information. Get info already we read. Get info, and we select here the 0. That means 0 indicate the first item. Okay, that means our first item of this study area, first item show as this value. That's why we use here that this get information, and this value or make a list as a 0. That means first item. Okay, so now we print it. Now we print it. Print this Dhaka area. Wait a minute. Same value we see here, but just for this is another way. Okay. Wait a minute. Just click the run. Okay. Wait a minute. So this one function is show as a object value. Object value is when you expand open, we see the object value is area is this value. And another way we use the values function. That means all of the value show as a directly. Okay, so all of same value show as this. Another way, just if you want to put here this name of this, suppose Dhaka. Okay, suppose we use the total emission area. Total emission area. Okay, total emission area of this Dhaka district. Now click the run. So now you see as this headline. Sorry, this headline show as a total emission area. It's
We cannot see the screen.
yeah.
Screen sharing may be not working.
Okay, wait.
It's visible for me.
Okay, it's another participant already see my screen. So you left from meeting and again join, please. Maybe your networking issue. Okay, so now we see here the total emission area, Dhaka area. You see here the headline total emission area. Okay, same value we see that we are one way is object value and expand it object, and same the value. This value is this image function show as a square meter. Okay, and another way is total emission area. We see this same value. Okay, same value we see this area. So it's not a big deal. So now we use here the now we see here the our now we already we calculate our study area. Now we calculate our all of the emitted NO2 emission gases. Okay, so now let's go. So now we suppose take a variable, and variable name is suppose mean NO2. If you want, you can use any variable, no problem. Mean NO2 SP. Okay, specifically, or mean NO2 SP. That's why we use here the mean NO2 again. So that's why. Okay, participant join. Okay, that's why we use here the mean NO2 specifically. Okay, suppose specifically we use the SP and call our mean NO2. Oh, who is our mean NO2? Mean NO2 was this our mean NO2. Okay, so we use the mean NO2. Okay, mean NO2, and same use here the reduce region function. Same equation we use the reduce region. That's why we copy this function. Okay, from this copy this function and put here. Okay, reduce region reducer we use here the mean value. All of the mean value of this NO2 we use the reducer the mean. All of the function scale value, all of the things are same. Now we use the print function. Now is the, what is the wrong issue? Okay, double dot user. Okay, so now we use here the print function for printing this value. So now mean NO2 specifically, simply copy and paste here. Now click to the run. So when you click to the run, you see here the another dictionary is computing, because we dictionary computing this value NO2 column number density. NO2 column number density, that means mean value of NO2 of all of our study area, mean NO2. We see here the 0.0001 0.0001 mole per meter square. Okay, this is mean value. And now if you want to same thing, if you want to check the value this directly, just we copy this function. Suppose we use here the total emission. Okay, total emission, we edit just it, total emission of NO2. Okay, total emission, that means we mean NO2 specifically copy and paste here. Then we use the values function. Okay, values function and print this total emission study area. Total emission, that means total emission NO2. Total emission NO2 mole per meter square. Okay, mole per meter square of Dhaka district. Okay, suppose we say not this, we say that NO2, just we put here the NO2 mean, then we use the mole per meter square. Okay, now click to the run. Now we see here the same value in our, here is the mean NO2 mole per mole per meter square. Now click to the run, and then we see here the, okay, wait a minute, mole per dictionary, open a mole per, that means we already we can calculate our total emitted area in square meter. Okay, total emitted area in our square meter. Then we calculate mean NO2 for our study area, and now we calculate total emitted gas in our study area. So suppose we take a variable, suppose take a variable name is total emitted NO2. Okay, total emitted NO2, and we call this E dot number. We show as a number value. That's why we said E dot number. Okay, E dot number value show as a total emission. Mean total emission value already we put at the mean total emission. Simply copy this value, mean value, this total emitted mean value, multiply with the total emitted area. Okay, that means total, what is our total emitted area? Total emitted area is our this Dhaka area, right? Total emitted area. Okay, Dhaka area, total emitted area. So simply copy, okay, mean and total emission, okay, call this value, and with the total emitted, that means Dhaka area. Simply copy and multiply with it. That means oxide mole per meter square density in the platform, sulfur dioxide as well. We edit this code and already we complete, and carbon monoxide as well as same. Okay, same to NO2 and SO2. And then how to download air quality parameter time series data also we learn in two way. Okay, and make time series chart any air quality parameter already how to export already we learn it, and make map layout, or the rest one is already rest one we learn after some time. So all of the things we already complete of our 5th days course item. So now we learn how to make map layout in ArcGIS application. So no problem.